Alright, this project, so this would be the previous project on the Olympic swimming, and I like you to continue in the same Desmos graph sheet, so to say, here. So I prepped it for you. I'm going to close this one down. Notice this is a folder here, and you can also add folders and notes and tables and so on. And so I'm going to close this one here, but notice that the data are still there until I just turn them off, or I can turn them back on, but I do want to have them off. So here are actually the folders, and that should be prepared for you. So every time that you complete a project on age versus height, and then ice cream cones and coffee and so on, just build on the project that you had completed prior. So I'm going to open this one here on age versus height. I'm going to turn this one on. There we go. And let's go from there. So there is a table for the age versus height statistics in the statistics book. So here it is, years and centimeters, but actually I don't like you to use that. I like you to use this one here because it's somewhat more comprehensive, and it has girls and boys in here. So only the heights for females, males, so on. And it goes from ages 1, 2, 3, all the way to 18. I'd like you to use all these data, and notice that they give ranges here. So 27 to 31, I'd like you to take the average of that. So 29, or between these two numbers, that's roughly 34, or between these two numbers, that's roughly 37. You don't have to be absolutely accurate here. So I'm going to go in here, and I'm going to start with the table. And there it is. I'm not going to call it X3 here because it's actually my second project in this unit 2. So I'm going to call it X2 and Y2. There we go. And then I have ages 1, 2, 3, and so on. And then I don't know if I'm going to have age 4. We'll see in a moment. Yeah, I do. But then pay attention that you have ages 6, 8, and so on. So again, I'm going to take these averages here, 29, 34, 37, again, 29, 34, 37, and click the little plus symbol and try it again. There we go, and then they show up. And we can already see that this is probably not going to be a curve. I'm sorry, this is probably not going to be a straight line. It's going to be a curved line because at some point there's going to be a limit. At some point when they're grown up, these girls, young women, then they're not going to grow anymore, right? So it should peter out, which means which of these curves are we going to use? And actually don't try to use the square root curve, because the square root curve actually continues on, and that's just not possible that we have girls and boys, women and men who are growing to be 20 feet tall, that kind of thing. So it should actually plateau out, or there should be a certain limit. So obviously this one is not going to apply either. This one here, it goes into the wrong direction here, and where you kind of know it's not a straight line. Well, it turns out actually it is the exponential if you flip it over, and that was for this particular one here. This was the discharging capacitor, which is this equation here. But if you use the one for the charging capacitor, where you had in parentheses 1 minus e to the kx, then that one was kind of flipped over. So I'm going to show you that. Let's see, where was it going to go? Where to go? Where to go? Oh, I clicked on the wrong. Oh, there we go. That's what I meant to click on. I confused myself. Hold on. I think I know what happened. I had too many windows open. There we go. That's a little better. So when I put that in here, I'm going to have y2 is proportional to m times, and now I'm going to open that parentheses, and this is the same as the charging capacitor, 1 minus e to the power, open the parentheses, k times, there we go, and now it's going to be x2, yep, that's right, parentheses, and I'm going to go 1 over, close the big parentheses, and this time around I'm going to make also a plus b, there we go, and we can already see that this one is going to at some point have a limit. Again, this is not the accurate curve. Young women, girls, they're not gonna limit out at 42 inches, obviously, kind of the way it looks like here. They're gonna be taller. So your final curve is actually gonna look different than this one here at a higher limit, and the same for the boys, by the way. But then you still have to pay attention to that. Well, yeah, look at the data, look at the curves that you get at the end, and notice that, ooh, do the data make sense? Or they probably will make sense. And does the extension of these curves into adulthood actually make sense? So yeah, pay attention to that. I should mention the source and citation for this one here. So I believe if I go back to this one here from the textbook, where they get these data from? Well, I'm on this one here. Well, where do they get the data from? Well, the short answer is these have been measured by pediatricians for ages, for generations, for all girls and boys. These have been measured by parents for generations, for all ages, for boys and girls, and so on. And of course, there are research papers, but that would be the source and citation behind that, obviously. All right, oh yeah, and I want to show actually what you're going to do with the boys data here. I think were these girls first? Yes, girls first. So I'm going to go in here, and here, just like before, I'm going to do Y22. There we go. And then here, I would be doing this here, Control C, and then do this one here, and then I would change this one here too. I just did Control V, by the way, but of course I could retype the whole thing. Now this one doesn't show anything because I don't have any data yet. So I'm going to go in here, and it looks like for boys that would be 30, make that 35, doesn't have to be exact here. So 30, 35, and then this one here looks like 38. So 30, 35, 38. Let's see, I'm going to go back to the table here. 30, 35, 38, and that would be for the boys here. And if I want to make the colors not kind of line up, then here green for the boys, and then I would change this one here also to green. And then if I really wanted to, I could also make these here circles and make them larger. And I can make for the girls here these crosses here, and also make them larger, that kind of thing. Forgot on the last project. And of course that's just for looks. And then, as before, yes, when you make your comments, ponder these questions here. So it seems that these data are simply supplied on this website without sources or citation, but I kind of already told you what the sources are, right? Do the data make sense? Well, once you have them plotted, they kind of you will see that they hit a certain limit, right? What kind of regression curve did you apply and why? Well, that's the kind of like flipped exponential, the way I called it here. So from the charging capacitor, the one before. What should happen to the height of girls and boys out their adolescence? Well, they should limit. But when you plot them and when you put the regression curve in there, notice where that limit is, and you will get a little surprised. And that is then the follow-up question. How could the data and the regression be improved? I think the word "be" is missing here. Be improved upon. So, yep. And that's it for this project. And I just looked this up. Indeed, there is a "be" missing there. Be improved upon.